Today we will be discussing Boyle's law. Boyle's law is going to state that the pressure of an idealized gas is going to be inversely proportional to its volume. Now remember that inverse means that as one goes up, the other one has to go down. The equation that is going to go along with this is going to be P1, that's going to be my initial pressure, times my V1, my initial volume, is going to be equal to my P2, or my final pressure, and that being multiplied by V2, my final volume. Again, this is just a little key here. If my pressure goes up inside of my problem, my volume has to go down. And if my pressure goes down, then my volume has to go up. They are inversely proportional to one another. The problem that we are going to work together is going to be, what would the new volume be if 3.2 liters of N2, that is the nitrogen molecule, at 0.67 atmospheres, increased its pressure to 4.8 atmospheres. Again, we are going to be utilizing guess, so I'm going to have to identify my givens. This is when I'm going to have to be very careful, as I have initial and final volumes, which means I need to be specially aware of words like initial, final, beginning, end, increase, decrease, those kinds of words that are transitional words where I know that something has changed. That's going to be able to tell me if I am an initial or I am a final. So we have what will be the new volume if 3.2 liters of N2 at 0.67 atmospheres. The word at is going to tell us that these are going to be connected. The new means that that's going to be my final, which would make my 3.2 liters my initial volume and my 0.67 atmospheres my initial pressure. I can also tell that my initial pressure has to be this number because immediately after this number I see increased my pressure, which would mean that I have changed something, so 4.8 is going to have to be my final pressure. So I've identified P1 and P2 and V1. The only thing that is left out of that equation is going to be V2, so I will identify that in my unknown section. My unknown is going to be my final volume. Now I'm going to go ahead and look at the equation part of my guess, and the equation is going to be Boyle's Law's equation, so P1 V1 equals P2 V2, and I'll go ahead and I'll write that down. Then I need to isolate for the appropriate variable. I don't know what V2 is, so I will isolate V2. I'm going to look at whatever operation V2 is currently in. V2 is currently being multiplied by P2, so that means I need to undo that operation. Undoing multiplication means I need to divide, and I need to divide by the variable that I do not want, so I will divide by P2. Once I do that, I will have a brand new equation of V2 is equal to P1 V1 divided by P2. Next, I will go ahead and I will substitute in all of my actual numbers into my newfound equation. My P1 is going to be 0.67 atmospheres. My P2 is going to be 4.8 atmospheres, and my V1 is going to be 3.2. This is where the majority of the mistakes are made. Make sure that in your given list you are very clear about which is P1, which is P2. Do not skip the step of writing them out, as it makes it difficult to correctly identify who is going to go where in your substitution. Then I will go ahead and cancel any units that appear twice on the top and the bottom, and atmospheres is going to appear twice, once at the top, once at the bottom. So I'm going to go ahead and cancel those, leaving me with the only unit left of liters, which is an appropriate unit for volume. So I'm going to go ahead and move on and solve that equation, which means I need to plug it into the calculator. So that would be 0.67 times 3.2 divided by 4.8. And that would give me this long number. Volume 2 is going to be equal to 0.446667 liters. Okay, this is a big long number. No one wants to write out this number, and we are going to go ahead and round that number to 2 decimals. So I would look at 1, 2, 6 makes me round up, so that 4 will turn into a 5, making my final volume 0.45 liters.